Consumption models and patterns of the electric grid refer to the ways in which electricity is generated, transmitted, and used by consumers. Understanding these models and patterns is essential for efficiently managing and planning the electric grid. Here are some key aspects of consumption models and patterns. Load profiles. Load profiles represent the variation in electricity demand over time. They can be categorized into different types. Residential, typically characterized by daily peaks in the evening when people return home from work or school. Commercial, characterized by relatively stable demand during business hours with occasional peaks. Industrial, often have stable base load demand with occasional spikes during production or processing. Seasonal, some sectors have seasonal variations in demand, such as heating or cooling loads. Peak versus base load demand. Grid operators must balance base load demand constant, non-variable demand with peak demand periods of high electricity use. Understanding the timing and magnitude of these peaks is crucial for grid stability. Time of use TOU pricing. TOU pricing models encourage consumers to shift their electricity usage to off-peak hours when electricity is cheaper. This can help smooth out demand patterns and reduce peak loads. Renewable energy integration. The integration of renewable energy sources like solar and wind can introduce variability into the grid. Consumption patterns need to be aligned with renewable energy generation patterns to maximize utilization and minimize the need for backup power sources. Electric vehicle EV charging. The adoption of electric vehicles introduces new consumption patterns. Managing EV charging, especially during peak hours, is essential to avoid grid congestion. Distributed energy resources DERs, such as rooftop solar panels and home battery systems, allow consumers to generate and store their electricity. These resources can change consumption patterns by reducing demand from the grid. Demand response. Demand response programs involve adjusting electricity consumption in response to price signals or grid conditions. These programs can help balance supply and demand during peak periods. Grid modernization. Advanced metering infrastructure (AMI) and smart grid technologies enable real-time monitoring of consumption patterns. This data helps grid operators optimize grid performance and respond to changing demand conditions. Forecasting and predictive analytics. Grid operators and utilities use data analytics and forecasting models to predict future consumption patterns. This allows for proactive grid management and resource allocation. Storage solutions. Energy storage, like large-scale battery systems, can store excess electricity during periods of low demand and release it during peak demand, helping to smooth out consumption patterns. Resilience planning. Understanding consumption patterns is essential for resilience planning, especially in the face of extreme weather events or other emergencies that can disrupt the grid. Electrification trends. As sectors like transportation and heating transition to electric power, consumption patterns will continue to evolve. Grid planners need to anticipate these changes. In summary, consumption models and patterns of the electric grid are dynamic and multifaceted. They are influenced by a range of factors, including technology adoption, pricing structures, renewable energy integration, and consumer behavior. Accurate modeling and effective management of these patterns are critical for ensuring a reliable and sustainable electric grid.